We are continuing with our data science videos. This time it is going to be on a temperature control lab, which is a continuation of our earlier video, that is the part 1. Here we are going to learn LSTM based temperature forecasting experiment. As you can see on the screen, the blue lines are a data set which are created from a heater and a sensor setup. Right now the heater is put off when it was heated, so temperature is going down. So the data set is created online by 59 points and predicts next 20 values. And also you are trying to verify the result is going to be in green. The offset is because of there is a dead time involved. So we are going to explain you in detail how this experiment is performed. So real-time temperature forecasting is what we are talking about. How to do temperature forecasting experiment using deep learning LSTM neural network model, which has been explained in the earlier video. The program will predict future temperature values from a temperature data set of 59 points each second and verify the prediction practically using a heater and a temperature sensor. So this is going to be a real-time experiment. As we explained in the last video, there is a device, microcontroller device, which reads from a temperature meter and puts into a computer. And there is a heater and a sensor which is attached in this setup. So a data set is created of the temperatures. That is what is the first step. All these things we explained in the last video. Still there is a temperature meter with sensor, you can see that, and it throws the voltage into this, and this microcontroller device will send out packets to the device through HTTP. And you can read further on how this entire device works or communication works in this published article which is given here. Now the LSTM model is trained on a time series dataset, that's online temperature data collected from the previous video itself, to learn patterns and relationship between past and future temperatures. The model is then used to make predictions for future temperatures. Now you can see here an upward trend prediction. The real-time temperature is continuously fetched from a device. You can take a look at the complete Python program. You need to import all these libraries as I explained in the last video. That is the NumPy, Pandas and the Matplotlib. An HTTP client for communicating with the device. There is a sequential model required, LSTM, etc. These are the different libraries. You can stop the video and take a look at it later. So the HTTP connection, as I mentioned in my earlier video, you can send a command 192.168.1.102/RPC/port1 read. It will send out the temperature. Instead of 15.8, it will send 0.158. So you can even execute that from a browser which is here. Now the host command is given with an IP address and a path which is combined, and you create a get command like this. And now how do you scan 59 real-time temperatures every second? So there is a function called read latest temperature which will scan each temperature every second. So you can take a look at this program later also, but I am going to explain you what it does. It basically reads temperature every 1 second. There is a delay time.sleep and returns. This function returns the temperature. Usually it returns the temperature 14.1. It may be returning 0.141. You have to multiply by 100 to get the temperature back. And now you can see 59 seconds, 59 temperature values have been collected when a heater is put on with a power, and you can see that the temperature is rising and they are appended to a Excel master.csv file. So once after it is recorded, the dataset, now you can read from the dataset and puts into a time series data variable, and data underscore CSV is basically reads all the data from a CSV file, and you can see all the 59 data are read back actually into the time series data variable, which is a time series data. As you know, in LSTM, you need to convert the data into different rows, and you can, this is called preparing data and sequencing the data. So when we select window is equal to 9, if there are 59 data, 59 minus 9, 50 rows will be created like this. First 9 data and 10th will be the prediction. Then this will be the format in which the data are pre-processed. You can see that actually the first, there are 50 rows, row 0 to row 49, and you can see first data, second data, third data, fourth data, fifth data, sixth data, seventh data, eighth data, ninth data. There will be prediction. So it makes a table like this. This is called data slicing process. There will be 50 rows and 9 data in each row, and finally there will be one Y, that is the Y. So you are basically formulating into 50 multiplied by 9, that is the initial rows, then the output is 1, and that is the feature output. Now you are basically doing all these things through a function called function prepare. In my earlier video also it was mentioned. You stop the video and later see it. The output is going to be basically you are passing n step is equal to 9. That means that is window is equal to 9, representing the historical data used to predict the next data point. So ultimately what you are doing, this function is making 50 such rows in this format, and after that you have to convert this into x.shape, basically to look like a 50 three-dimensional array, 591. That is what this particular command does. This is being done to project or pass it to an LSTM function to build a model. So while building model, you know that this is a sequential model, which we explained in the last video also. All these commands are required there, and you are also having 50 units, that is 50 neurons. In this particular case there are 2 LSTM layers, one after another. Then you are adding a dense output layer. These things were also explained in the last video. Now you need to fit the model. Fitting is done. The X and Y data which you have sequenced in a particular format, and they are passed into fitting. The epochs means 300 times the epochs will run. So now at the end of this you can see that specify the number of times the epochs, the entire data set is passed forward and backward through the neural network and undergone 300 training iterations. Now once if it is done, this is all done online. You see that it's collected 59 data in 59 seconds, and few seconds for, let's say 10 seconds it is taken for compiling, fitting, etc. Now once a model is made, then prediction of next real time temperatures. Now using the model you have to project next 20 points like you see in the red, and try to also collect the real temperatures which are coming to verify the model, projected forecasted model. See, the prediction is done like this. You have again, you will take last 9 data and try to predict the next number, and you know the entire programming in this can be understood through a following diagram. See, initially when I is equal to, I goes from 0 to 19, that is 20 times it iterates, 20 times it predicts. First time, you know the 50th data, 51 data, 52 data, and up to 58 data is here. You remember the last row when we sequenced. That is being passed into, this is X input. This is called x underscore input. And whenever I is equal to 1, it will predict the first value. You can, when I is equal to 0 exactly, so here it is 0 to 19, that means 20 times. I is equal to 0 means it will predict the first value after this 59. After that, you are basically adding x input, that means whatever was here, and you appended one more value, prediction 1. Then it will predict on the P1 again one more time when I is equal to 1, that is P2. Again it will predict P3, again it will predict P4. So it will go on predicting 20 times. So every time it predicts the last 9 datas, these are two combined. So this temp input gets an addition of this yellow register and the green ones. That means this many data will be there. Every time it predicts, the last 9 data will go into the prediction. So that is what initially, this will only be there, I is equal to 0, it predicts and puts it 1. Next time one more came, P2. So last 9 data, that means from the beginning of x input, some data will be omitted when it is passed into the model prediction. So it predicts on the latest data. It goes on predicting 20 times. That is what this program does. You can see that the entire process, what I explained here, is can be understood from this program easily. Now, these are all predicted 20 values. You can see that which is stored in first output and which is to be simply plotted. That is the red line. Now, this explanation is same as what I have shown in the earlier. Now real-time temperatures have to be scanned actually to verify the results, the forecasting is correct or not. So what you do is, this is the forecasting in red, you read the temperature one by one. So this gap in temperature, it should have sit on one hour or other. This is because there was a compile time 10 seconds, there was a dead time. During that time the heater was on. So because of that, you see that this temperature will be maybe 1 or 2 Kelvin above temperature, 1 or 2 degrees above. So these are the simple plotting programs to plot the curves which I have shown here. And now, whenever it goes through I is equal to 0, I is equal to 1, I is equal to up to 20, the first output gets updated with the new forecast. See, it goes on appending 20 times, it will do that. And this is stored in first output. The first output can be simply plotted. That is nothing but, this is the forecasted one, and you simply read one by one the temperatures and try to, this is the forecasted one, and try to plot the green one is the real temperature which you have got here in this y hat. So that is how the real-time temperature forecasting is done. Where is a downward trend, this is the forecasted, and this is what we have got. Both are working fine. The videos will continue in the future. Thank you.